Okay students, today we will be discussing about implementation inheritance. Take a look at the figure carefully. Some of the classes which are very similar in operations are already implemented and they are doing the same job as the desired class implementation. Now for example, look at the two things shown here in the diagram. We have a list class and a stack class we need to implement. So if we try to look how to subclass the stack class from the list class, because list class is already existing here and we require the implementation of stack class. So we are looking towards what are the things that we can inherit from the list class to the stack class. So stack class needs three methods, that is push, pop and talk. Whereas list class is having two methods, add and remove. Push and pop is similar to that of add and remove. So we can inherit add and remove from the list class to the stack class. Now the issues here is there are problems with implementation inheritance. Some of the inherited operations might exhibit unwanted behavior. Secondly, what happens if the stack user calls remove operation instead of pop operation? When we are inheriting remove, because remove and pop, they behave in a similar fashion. So what will happen if the stack user calls remove function instead of pop operation? And what will happen if a super class implementation is modified? If we are going for some additional functionality to be introduced into the super class, then what will happen? The subclass developers is exposed to internal information about the superclass, and this may result in tight coupling of the subclass to superclass. When these subclass developers, they try to expose the internal information, they try to pass the internal information of the superclass to the subclass. There occurs a tight coupling between the subclass and the superclass. The dependencies are more likely to occur here. Let us have a look at type of inheritance we have. We have inheritance being classified into two broad categories, that is taxonomy and inheritance for reuse. Taxonomy is further divided into two types, that is inheritance detected during specialization and inheritance detected during generalization. Whereas the other type, the other class we have as inheritance for reuse, which have further two subcategories, specification inheritance and implementation inheritance. Now here we try to find out the differences between implementation inheritance and interface inheritance. Implementation inheritance is also called as class inheritance. The basic idea is to extend an application functionality by reusing functionality in parent class. So we are extending the functionality by making use of the existing functionality here. We inherit from an existing class with some or all of the operations already implemented. So we have two options here. Either we can reuse some of the existing functionalities or from the parent class, or either we can use all of the operations from the parent class. On the other hand, interface inheritance is also known as subtyping. Here we inherit from an abstract class with all operations specified but not yet implemented. This is the basic difference between implementation inheritance and interface inheritance. We are trying to make use of those abstract classes with all of its functionalities which have not been implemented yet. Whereas in implementation inheritance, we are making use of already implemented operations. Next point is delegation. Delegation is an alternative to implementation inheritance, and it is also as powerful as implementation inheritance. Now here a class is said to delegate another class if it implements an operation by resending a message to another class. See here, delegation, it is as powerful as implementation inheritance. But see here, there is a message passing between one class to another class. So we can say a class delegates to another class if it implements an operation by sending a message to another class. Delegation also makes explicit the dependencies between the reused class and the new class. So there are explicit dependencies which are done in delegation. It includes two objects in handling a request. One object is designated for receiving delegates. A receiving object delegates operation to its delegate. The developer can make sure that the receiving object does not allow the client to misuse the delegate object. Now this figure shows the difference between delegation and implementation. Here we need to find out some of the characteristic features, as we are saying that delegation is similar to implementation and it is as powerful as. Okay, sorry for interruption, students. So here we have the differences between delegation and implementation inheritance. As we are saying that delegation is as powerful as implementation inheritance, there must be some difference between them. So inheritance, this extends a base class by a new operation or overriding an operation, whereas in delegation, caching an operation and sending it to another object takes place. Now, which of the following model is better for implementing a stack? If we carefully examine here, we have in list two operations, add and remove, which can be inherited in stack like push and pop. Either we can do this by uh, implementation inheritance, or we can have a delegation. So a class stack delegates to the class list by passing a message. Now let us have a look at the design patterns. Design patterns are actually the template solutions that the developers have to refine over time to solve a range of recurring problems. Those problems that occur time to time. In order to solve those problems, developers look for template solutions, and these template solutions are actually the design patterns. The design pattern has four basic elements. First one is the name that uniquely identifies the pattern from the other pattern. So every design pattern should have a name, and that name must be a unique name for identity. Second element is problem description. Problem description here describes the situation in which the pattern can be used. Third one is the solution, that states a set of collaborating classes and interfaces. And the fourth one is a set of consequences, which describes the trade-offs and alternatives to be considered with respect to design goals being addressed. Now here we have a table that shows the selected design pattern and changes they anticipate. So it is actually a reuse activity. We are selecting design patterns and components here. To the left hand side, we have design patterns such as bridge, adapter, strategy, and to the right hand side, we have its corresponding anticipated change. Further extending the table, here we have abstract factories as the design pattern, commands, and composites. Now here are the applications of design patterns, where these design patterns are applicable. A wide variety of application domains exist here, such as drawing editors, banking, CAD, CAE, cellular network management, telecom switches, program visualization. So these are the application domains of design patterns. There are again a wide variety of technical areas where design patterns are applicable. This includes user interface, communications, persistent objects, OS kernel, and distributed systems. Now we'll look at interface specification in depth. There are various activities which are included in interface specification. To name them, we have included some of them, such as identifying missing attributes and operations. Here you need to identify what are the attributes or operations that have not been included up till now, and these have to be included to specify certain functionality. Then specifying type signatures and visibility, specifying invariants, specifying postconditions and preconditions. Here we introduce OCL. OCL we mean Object Constraint Language. It is the language for specifying invariants, preconditions and postconditions. Let us have a look in depth. What are the concepts associated with interface specification? Here are the principal components or concepts of interface specification, such as class implementer, class extender, and class user. Then we have to see for types, signatures, and visibility. Then contracts includes invariants, preconditions, and postconditions. Again, we will be looking at object constraint language, OCL collections as sets, bags, and sequences, OCL qualifiers for all and the exist. Let us see what do we mean by class implementer, class extender, and class user. Now the role of class implementer is for realizing the class under consideration. It is responsible for realizing the class which is under consideration. Then design the internal data structures. Further implement the code for each public operation. And for them, the interface specification is a work assignment. Class user invokes the operation provided by the class under consideration during its realization of another class called as the client class. Interface specification here discloses the boundary of the class in terms of services it provides. Now class extender develops specializations of the class under consideration, the class we are dealing with. So class extender will develop specialization for that class and may invoke operations provided by the class of interest. It also focuses on specialized version of the same service. Interface specification specifies the current behavior of the class and any constraint on the services provided by the specialized class. Now here we have an example of class implementer, a figure showing class implementer, class extender and class user in UML diagram. Look at the developer here. The developer is again having an interaction with the class user, class implementer and class extender. Class user calls up for a class. Class implementer realizes the class and class extender refines the functionality of the class. Now the next point here is type, signatures and visibility. By type, we mean an attribute that specifies the range of values the attribute can take and the operations that can be applied to the attribute. For example, consider the attribute maxNumPlayer for a tournament class. Now here we are having a tournament class. So maximum number of players that can be included in a tournament is given by the attribute maxNumPlayer. Now this attribute represents a maximum number of players who can be accepted in a given tournament. Its type is integer, denoting that it is an integer number. Signature is the operation parameter and return values are typed in the same way as attributes. Now given an operation, the tuple made out of the type of its parameter and the type of the return value is called the signature of the operation. For example, the signature of accept player function here is then the accept player into bracket player colon void. So what is its signature? The return type value which the operation is going to return to us, to the calling function, indicates here the signature of the operation. Visibility of an attribute or an operation is a way for specifying whether the attribute or operation can be used by other classes or not. Now UML defines 4 levels of visibility. First one is private. Now here attribute can be accessed only by the class in which it is defined. Second level of visibility is protected. Here attribute or operation can be accessed by the class in which it is defined and by any descendant of that class, that is any immediate derived class. The third one is public. An attribute or operation can be accessed by any class if we define its visibility as public. An attribute or an operation with visibility package can be accessed by any class in the nearest enclosing package. Now here we have contracts. Into contracts there exist invariants, preconditions and postconditions. So contracts are actually the constraints that we are placing on a class that enables the class user, implementer and extender to share the same assumptions about the class. So a contract will define the class which will help the class user, extender and implementer to share this same information about the class. And this includes 3 types of constraints. Invariant, which is a predicate that is always true for all instances of a class. Invariants, these are those things that will be true always. They are not going to change here for all of the instances of a class. Now by precondition we mean that must be true before an operation is invoked. Before actually an operation is triggered, this precondition exists and that is true. Postcondition is a predicate that must be true after an operation is invoked. Now here we have an example to better understand what do we mean by invariant, what do we mean by preconditions, postconditions. So let us consider an example of a tournament. It provides method called as accept class. Accept player. This method add a player in the tournament. Then we have another method known as remove player. This method is responsible for withdrawing a player from the tournament, that is removing a player from the tournament. We have another method called as get max num player. It will get the maximum number of players who can participate in this tournament. Now looking at this example, we have invariance as the maximum number of players in the tournament should be positive. Invariant is the condition that we are placing. The maximum number of players should be positive in number. This is an integer number. It should not be in negative. It should always be in a positive number. If a tournament is created with a max num player, that is 0, the accept player method will always violate its contract and the tournament will never start. This is the condition again. where we do not have, where the maximum number of players that will be participating in this tournament, if it is zero, that means here some conditions are violated. If the tournament is having zero players, the tournament will never start, and the accept player method conditions are violated here in its contract. Now, a precondition for accept player method, we can place it as the player to be added has not yet already been accepted in the tournament, and that the tournament has not yet reached its maximum number of players. So preconditions that we are placing over the accept player method is the player that we are adding here has not been already in some other tournament added, and also the maximum number of player value has not been reached. If it has been reached, then we cannot add more players to it. So these are the preconditions. Let us see now what can be the post conditions for this accept player method. It can be the current number of players must be exactly one or more than the number of players before the invocation of accept player. Before we actually triggered the accept player, it should be either equal to that or it should be equal to exactly 1. This is the post condition for accept player. That's it for today. See you in the next class.